Hi everyone. So first I want to clarify a little mistake in the last video where I have said when MPL equals 0 here, MPL the green curve, when MPL equals 0, I have said that the TP, total product, start increasing. Actually what I meant is that when MPL equals 0, TP reaches its maximum, and when only MPL becomes negative, here TP will start decreasing. Okay, when MPL becomes negative, TP start decreasing, which means that when MPL equals 0, it adds nothing to the total product, which means total product reaches its maximum. Now we will see in case we have a function instead of table. In the last example we saw this table. We have table different quantities of labor and different total product for each quantity. Now imagine that we have a function, something like this. The total product function of let's say this is a workshop. It is TP equals minus 0.5 L to the power of 3 plus 6 L squared. First we can calculate APL easily. As we know that APL is actually TP over L, which means the total product over the total number of worker. So we can simply apply this formula here, TP over L, which means this over L, and we will find minus 0.5 L squared plus 6L. Now how to find MPL? Actually we know that MPL is the change in total product over the change in labor, or the derivative of TP with respect to L. So simply MPL here is TP is the derivative of TP with respect to the labor, and here we find the slope or the derivative. Okay, now let's do a quick reminder on how to calculate derivative of a function, which tells us the rate of change or the slope of the function at any point. So if we have fx as a function, ax to the power of n, any number, then the derivative of fx is simply a times n x to the power of n minus 1. So for example, if we use this rule on this function, fx equals 3x squared, if we apply the rule here, so what will you do? We multiply the exponent by the function, which means 2 times 3, which is 6 here, and we subtract 1 from the exponent, which is here x squared, which becomes h to the power of 2 minus 1, which is x to the power of 1, which is simply x. So the derivative of fx equals 3x squared is simply 6x. Okay, so if we apply this rule here in our example here, we will find 3 times 0.5, which is minus 1.5 L squared. We subtract 1 from 3, it becomes 2, plus 2 times 6, which is 12 L to the power of 2 minus 1, which is L. So this is MPL. And finally, now to find the maximum TP of this workshop, we simply set MPL equals 0. MPL, we found it here, this function, this equation of MPL, we set it equals 0 because the condition we said that to reach the maximum, MPL should equal 0. And when this happen, exactly when this equation equals 0 here, and we can by factoring this equation, we find 1.5 L times minus L plus 8 equals 0, which means either L equals 0 or L equals 8, and L equals 0 doesn't make sense in production. So the total product here, the optimal labor that helps to achieve the maximum TP, total product, will be 8 workers. And we can find what is this total product by replacing this value L equals 8 in this equation. So after replacing 8 here in this function, we will find the total product max. And here we replace, as we said, L here by its optimal value, which is 8, and we will find TP equals 128 as the maximum TP that this workshop can achieve, can reach. And that's all for MPL, APL, and max TP in case of we have a function. And I wish you good luck.